Hello everyone, this is Jivika Kanchalla and I'll be explaining you guys the solving of the first question of homework 4 in the course Probability and Stochastic Processes. Now let's have a look at the question. Find and draw f of y of 5, which is the cumulative distribution function for y, and the probability distribution of y in terms of the cumulative distribution of x and the probability distribution of x. Now, given that y is equal to g of x will be equal to 2 for x is less than 0 will be equal to 0 for 0 less than or equal to x, and x less than 1 will be equal to minus x plus 1 for 1 less than or equal to x less than or equal to 2, and will be equal to minus 1 for x greater than 2. Now let's look at the solving for this question. Therefore, given y is equal to g of x, and these are the parameters given. So for these parameters, let's plot the graph and see how that looks. Therefore, we know for x is less than 0, the value of y will be equal to 2. Therefore, for x less than 0, the value of y will be equal to 2. And the value of x is equal to 0 if the value is between 0 and 1. For x 0 and 1, the value of y is equal to 0. So that will be this straight line. So for in between 1 and 2, for x, the value of y will be minus x plus 1. Therefore, y is equal to minus x plus 1. This will be the graph between 1 and 2. And if x is equal to greater than 2, then the value of y will be minus 1. Therefore, at 2, the value will be equal to minus 1. We can see that the cumulative distribution function over y will be equal to 0 and 1 if the value of y is less than minus 1 and if the value of y is greater than 0. Therefore, for the value of y between minus 1 and 2, at y is equal to 1, the probability of y is equal to 1 is equal to probability of x greater than 2, which is equal to 1 minus the f of x of 2, which is equal to 1 minus probability of x less than or equal to 2. And at the same time, at y is equal to 0, the probability of y is equal to 0, which is equal to probability of 0 less than x less than 1, which is equal to f of x of 1 minus f of x of 0. Similarly, at y is equal to 2, the probability of y will be equal to 2, which is equal to probability of x less than 0, which is equal to the f of x of 0. Now, when y lies between minus 1 and 0, that is minus 1 and 0, which is this part, the cumulative distribution function will be equal to probability of y less than y, which is equal to probability of 1 minus x less than or equal to y, which is equal to the probability of x less than 1 minus y. Therefore, the cumulative distribution function of y will be equal to 1 minus the cumulative distribution of x over 1 minus y. Therefore, for y between 0 and 2, the cumulative distribution function for y will be equal to 1 minus p of x less than 0, which is equal to 1 minus f of x of 0. Therefore, we can write the cumulative distribution of f of phi in terms of f of x as the value will be equal to 0 if y is less than minus 1. It will be 1 minus f of x of 1 minus y. If the value of y is between minus 1 and 0, it will be equal to 1 minus f of x of 0. If the value is between 0 less than y less than 2, it will be equal to 1 if y greater than 0. Now we can represent this as follows. That is, if the value of y is less than minus 1. So if the value of y is less than minus 1, it's going to be 0. If it is between minus 1 less than y and 0, that is, if it is between this part, it will be 1 minus f of x of 1 minus y. Therefore, this will be the graph. And if the y is between 0 and 2, that is between 0 to 2, the value will be equal to 1 minus f of x of 0. And if y is greater than 2, that is after this point, the value will be equal to 1. Now, if we differentiate this, we will get the value of the probability distribution function. So the probability distribution function will be equal to 1 minus f of x of 2 when y is equal to -1, and f of x when y is 1 of 1 minus y, when the value of y is between -1 and 0. As you can see here in the picture, so when the value is between -1, this will be, and it's going to be this when the value is between f of x of -1 and f of x of 0 at y is equal to 0, and this will be the value at y is equal to 2, and otherwise it's going to be 0. So this is the solving for the first question of homework 2.